So we do want the missing leg length of this right triangle. Again, they're telling us it's a right triangle, so even though they're not showing the right angle, it does exist right there, which would be a 90-degree angle, which means that we can use the Pythagorean theorem. So on this one, it says that I'm going to start with the leg. Now this leg is 6. In the last few problems I made the first one 6. This one, just to show you that it doesn't matter, because it doesn't, I'm going to make the leg right here instead. So that's going to be where the 6 is. And the other value that they gave us is the 7, which is not making the right angle right there. So that means that the 7, it must be a hypotenuse. So my hypotenuse then is 7. Now, I've got a leg squared plus 6 squared equals 7 squared. All right, so we're ready to do some evaluating. For example, 6 to the power of 2, which I just put in the calculator, is 36. And 7 to the power of 2 is 49. Some of you may have that down because 6 times 6 is just 36. And 7 times 7 is 49. If you have that down, that's pretty good. But now I've got a leg squared plus 36 equals 49. And what I would like to do is take this and just solve for a leg squared. I can't get rid of that power of 2 until I use the principle of equality next, which I'm going to do. So whatever I do to one side, I'm going to do to the other side. And again, the idea here is to take that leg squared and just be able to drop it so that it's all on its own. Which means that 36 right here, I can't have it. Positive 36, I got to zero that out by subtracting 36. If I do it to one side, I must do it to the other side as well. So this will give me leg squared because the 36 is going to zero out. We planned that. We forced that to happen. But then 49 minus 36 is going to be 13. And then what we want now is not leg squared, but we want just a regular leg to equal something. So to do that, I'm going to square root both sides. And if I do it to one side, I must do it to the other side, just like I would a principle of equality. And when I put this into the calculator, this is the number it gave me. All right? Now, the reason why this decimal is really, really ugly is because it's considered irrational, which we covered in 8th grade stuff. But it says up here, please round to the nearest tenth. So I will. So I would like the leg, but I would like it rounded to the nearest tenth, which means that I would look down here. The 10th place value has a 6. Immediately to the right is a 0, meaning the 6 will remain a 6. And so I end up with 3.6 as my final answer for the missing leg length. And I'll put that in here, 3.6. That's it. Now, one of the students was asking, well, why is this side longer than this side? It's because I did not draw the triangles proportionally because I don't care. And be careful, because they may do this on the assignment where they're going to be like, look at this one right here, and this one's much longer than the 6, but it shouldn't be because it came out as 3.6. Don't worry about that stuff, okay? Because all we need to know at the beginning was a right triangle. So again, the picture is just meant to help us to have a visual of what is happening, even though it may not be completely accurate.